This is the final exam review for Math 70, Intermediate Algebra II. I'm just going to be doing a few problems that were given to me from my last class. The problems that were given to me were numbers 32, 37, 50, 80, 81, and 89 from the final exam review packet that everybody should be studying for their final exam. Alright, so let's start with number 32. Suppose that a computer store just announced a sale. The sale is for an 8% discount in the price for a particular computer model. If the discounted price is $2,162, find the original price of the computer. Well, the original price is X, because we don't know it. We're going to be subtracting the discount from X. That discount is 8% of X. And then we're going to set that equal to the sale price, which is the $2,162. Now we can't work with percentages here, so we're going to have to convert our percentage to a decimal or to a fraction. I'm going to choose to convert it to a decimal, and I'm going to multiply that with X. Alright, now if I subtract 0.08x from 1x, I can do that here. If I take away 800ths from 1, I'm going to end up here with 92 hundredths, or 0.92. So I'm going to write down 0.92x is equal to 2,162. Now in order to solve for x, I'm going to divide both sides by 0.92. Now to do this division right here, I'm going to have to use a calculator. I don't have my calculator out, so give me a second. I'm going to have to take out my calculator. While we're waiting for me to take out my calculator and get this calculation, you guys should be doing this on your own. You should be taking out your own calculators and doing this division. So go ahead and divide 2,162 by 0.92 and get that answer. Okay. So it looks like I got that answer now. That answer is going to be 2,350. Alright, since that's our final answer, and since we ended up solving a word problem, I always like to write my answer as a sentence. So we're going to write this sentence out. The original price is 2,000. Oops, I messed up there. I meant 2,350, and we're just going to box that answer in, and that's our final answer for that one. Alright, good. Alright, let's go on to the next problem that we have right here. Our next problem is going to be problem number 37. Peg walks 10 miles in the same time it takes May to walk 6 miles. If Peg walks 1 mile per hour less than twice May's rate, what is the rate at which Peg walks? So I've already gone ahead and drawn two pictures here because I'm a very visual person. I like to see this all drawn out. I wrote here that Peg goes 10 miles in the same time, that's key right here, same time that May goes 6 miles. In order to do this problem, we're also going to need a special formula. You guys should have this formula memorized. Distance is equal to rate times time. We can also write that as d is equal to r times t. I'm going to solve for t because those keywords, the same time, is telling me that I'm going to have to set Peg's time equal to May's time. And I'm going to be representing time as a distance divided by a rate. Alright, so let's go ahead and do this. D stands for distance. Our distances here are 10 and 6. We need a rate in order to be able to do this problem. We were given some information about rates. So let's go back here to the word problem and let's try to figure out a way we can rewrite the rate for each one of these. It says here, if Peg walks 1 mile per hour less than twice May's rate. Alright, so since it's comparing Peg to May, I'm going to write May's rate as X. Or actually, let me use the letter M, because since May starts with the letter M, it might be better to use an m to represent May's walking rate. And I'm going to use a letter P. Actually, I'm not going to use P. I'm going to use the expression here that I'm going to get from the 1 mile per hour less than twice May's rate, which is 2m minus 1, which is going to equal Peg's walking rate. Alright, now we've got the rates represented as algebraic expressions. So now we're ready to go ahead and set up our equation. I'm going to set up my equation. Remember that the keywords same time are going to tell us that we're going to represent Peg's time equal to May's time, and I'm going to represent that time as a distance divided by a rate. Alright, so it's going to be Peg's time is equal to May's time. Peg's time is going to be represented as a distance divided by a rate, and May's time is going to be represented as a distance divided by a rate. Peg's time is going to be 10 divided by her rate, which is 2m minus 1. May's time is going to be represented as a rate, which is 6 divided by m. In order to solve this rational equation, we could cross multiply, or we could multiply the entire equation by the LCD. I'm going to choose to show this by multiplying through by the LCD. We'll get the same result either way. Okay, now we're going to go through here and we're going to cancel out any common factors. Alright, so I'm going to be left here. I'm going to have to distribute this 6 right here to both of these terms. I'm going to be left here with 10m is equal to 6 times 2m is going to give me 12m, and 6 times negative 1 is going to give me minus 6. Alright, I'm going to combine all my common factors, get all my m's to one side, so I'm going to subtract 12m to both sides of the equation. That's going to leave me with negative 2m is equal to negative 6. Now we can isolate the m by doing the inverse operation. We can divide both sides by negative 2. So m is going to be equal to 3. Now this m represents May's walking rate. Now the question in the problem was not looking for May's walking rate, but I know that if I were giving this problem in a test, I would most likely ask for you to find both walking rates and see if you could be able to differentiate between the two rates. So I'm going to go ahead and write this as if it were part of the answer, even though I know it wasn't asking for this. May walks 3 miles per hour, so we're going to go ahead and box that in to show that we found that. But the actual problem was actually looking for Peg's walking rate. In order to find Peg's walking rate, we're going to have to go back to the expression 2m minus 1, and we're going to have to substitute m equal to 3. So that'll be 2 times 3 minus 1, which is going to give me 6 minus 1, which is equal to 5. So Peg's walking rate is going to be 5 miles per hour. Alright, and that's it for this problem. We're ready to go on to the next problem. Alright, this is number 50. One of the following problems is an equation to be solved, and the other problem is an expression to be simplified. Solve the one that is an equation and simplify the one that is an expression. For the one that is an equation, be sure to check for extraneous solutions. Alright, so first thing you do is you're going to look for any equal signs you see here. That's going to give you a hint that it's an equation. So B has an equal sign. So let's write that in there that has an equal sign. And we're going to label that as our equation. Okay, if we look at letter A has no equal sign in it, so therefore that is an expression. Okay, so let's go ahead and let's start off by simplifying A. We're going to simplify A by finding the LCD, making sure that we have that same LCD in all of these fractions, and then combining all these fractions to a single rational expression and then simplifying. Okay, so let me go ahead and rewrite the problem right here. First thing we're going to have to do is we're going to have to make sure that every single one of these denominators is factored out so that it's easier for us to determine what our LCD is. And I can already tell that the x squared minus 4 is not factored. The factors of x squared minus 4 are going to be x plus 2 and x minus 2. And hopefully you guys can see that that is the difference of two perfect squares, and that's what it factors out to be. Alright, so we're going to have to multiply our first rational expression by the factor that is missing in the denominator to have that LCD. So this one's missing an x minus 2, so we're going to multiply by that to the numerator and the denominator. The second fraction is missing a factor of x plus 2, so we're going to multiply by that to the numerator and the denominator. Okay, so now we're ready to distribute here. I'm going to start off by distributing this x on this first fraction. So x times x and x times x minus 2. And we're also going to distribute this negative to each one of these terms, to the x and to the negative 2. It's like we're multiplying by negative 1. So we're going to end up here with x squared minus 2x minus, all over x plus 2 times x minus 2. And I'm going to write here plus because I'm distributing that negative. So this is going to be negative x minus 2 over the LCD of x plus 2, x minus 2. Plus, we're going to have negative 8 over those factors of x plus 2 and x minus 2. Now we're ready to combine like terms. So this is going to give me x squared minus 3x minus 10 all over that LCD. Next step is to make sure that this is completely simplified. So what we're going to have to do is we're going to have to factor out the numerator. The numerator is going to factor into x minus 5, x plus 2. So now we actually see that there is a common factor between the numerator and denominator. There's a common factor of x plus 2. We can cancel those out. So let's go ahead and cancel. And we're going to be left with x minus 5, x minus 2. And that's going to be our final answer for that problem. Okay, let's go on to part B. Let's solve this equation. We're going to need to multiply through by the LCD. Let me go ahead and erase some stuff here so I have more space to work with. And I'm going to go ahead and put parentheses here. I'm going to multiply through by the LCD to the numerators in order to get rid of the fractions. This is different from what we did for part A. All right, you can only do this when you have an equation. So we're going to multiply this LCD to each one of these fractions. We're going to multiply it to the numerator. Okay, we do not want to get the same denominator in this problem. We want to multiply this to the numerator so that the denominators end up canceling out with the numerators. Okay, so this is going to be x times that LCD all over that x plus 2 minus, and that we had that 1 times the LCD all over that denominator of x minus 2 equals, and we have an 8 over the factors of that x squared minus 4. Oops, let me make some more space there. It's going to be 8 times that LCD right there. All right, now we're ready to go through and cancel out any common factors that we may have here. Remember, this was our goal. Our goal was to get rid of those denominators so we end up with no fractions. All right, so we're going to end up simplifying what we have left here. I'm going to distribute this x to both of these terms. This is going to give me x squared minus 2x. I'm going to distribute this negative to both of these terms right here. So that's going to give me negative x minus 2 is equal to 8. All right. We have a quadratic equation, so we're going to combine like terms, and we're going to set this equation equal to 0. That's what you do every time you have a quadratic. So your first goal when you have a quadratic equation after you set it equal to 0 is to try to factor it. If it's not factorable, then you would turn to the quadratic formula, or you would do completing the square to solve this equation. Fortunately for us, this equation is factorable, so we're going to factor into x minus 5 times x plus 2, then set that equal to 0. Each one of these factors set equal to 0. And that's going to give us possible solutions of x equal to 5 and x equal to negative 2. Remember, I said these are possible solutions. We need to check them because these might be extraneous. One might be extraneous, or both of them might be extraneous, right? Or they both might work. Okay. So now we're going to start off by checking the first possible solution there. We're going to start off by checking that x equal to 5. I'm going to copy down the original equation just to make sure that I'm substituting everything in here correctly. Okay, so that's going to give me a 5 over 5 plus 2 minus 1 over 5 minus 2 is equal to 8 over 5 squared minus 4. This is going to come out to 5 over 7 minus 1 over 3 is equal to 8 over 25 minus 4. I'm going to need a common denominator in order to combine these fractions. The LCD here is going to be 21. So we're going to go ahead and multiply by 3 to the numerator and denominator. I'm going to multiply this fraction by 7. So that's going to give me 15 over 21 minus 7 over 21 is equal to 8 over 21. And this comes out true. So this solution, x equal to 5, is good. I'm going to box that in so that I can show here that it is a solution for this equation. Now we need to check the x equal to negative 2. When I substitute x equal to negative 2, it appears that we're going to end up having a problem here. I end up with negative 2 plus 2 in the denominator, and that is bad. We cannot have 0 in the denominator. Because when you have 0 in the denominator of any fraction, that is undefined. Therefore, this negative 2 is an extraneous solution. We do not want to include that in our solution set. I'm just going to go and I'm just going to cross out that x equal to negative 2 over here on the other side just to make sure I'm not tempted to include that in my solution set. So let's just go and cross it out. Cross, cross. There we go.